So this is my final project. It's called Duck Lake Dash. One class is the animated sprite sheet. This does basically the same thing as the one from the poker project. I have a duck class that handles anything to do with the duck, which is the main character in the game. We have clocks to deal with cooldowns, as well as I use a clock for scaling when the duck jumps so that it looks like it's coming out at the screen gradually and then going back down. Other clocks, I used a lot of clocks in this project. That was something that I got a lot of practice with. Also just a general update position function to update any relevant stuff for the duck. I have a button class, which is basically the same as the one from the calculator used in the splash screen. I have an event manager, which has an enum of like different game states. So that's going to let us know whether it's the start screen, so we should be drawing a splash screen, or in-game, we need to manage all the obstacles and the duck and all that stuff. Fonts is the same as the calculator, just loads in the fonts. Mouse events also the same as the calculator, checks for whether the button's clicked or hovered. And then we have an obstacle class, which handles the obstacle sprite, its movement, checks for hits. It has the hitbox. For the hitbox, I use the float rect because I found out that that's faster than using a traditional rectangle shape. Then I have the splash screen, of course, and I used this more than once, actually. I used it at the beginning of the game, but also if you lose the game, you can play again, and there's a splash screen. Or if you beat the game, you can play again, and there's a splash screen. For a few things that I had trouble with this game, the obstacle movement was challenging to get down. They were moving really slow at first, and their speed was kind of like tied to the movement of the duck. If you were pushing the arrows more, the obstacles would move faster, and I found out after doing some research that this had to do with them both being in the same pull events loop. I guess if there's like more events, it can cause everything to go faster because it gets called more. And then another thing that I ran into was that when the hitboxes were getting near the duck, when the duck was colliding with the obstacles, everything just slowed down and glitched out a bunch. So one thing that I found while researching that was really helpful for that was to reserve space for the obstacles. And then another thing that made a massive difference was actually quite simple, which was to check the hits first and then check all the other conditions. At first, I was checking all of these conditions in like one if statement, basically. And doing that really slowed everything down. So once I made it so that I'm only checking these if the hit is true, if the obstacles and the duck have collided, that really sped everything up. Now to show the game quickly, when I run it, you'll see that there's a splash screen and a button to start the game. And then you control the duck with the arrow keys. And if you lose, if you hit an obstacle, you can play again. There's left and right arrows to move left and right. And then you can go under the water by pressing the down arrow, which also allows you to avoid obstacles. You can fly by pressing the space key, which has a recharge but is very powerful when you use it because it makes you impervious while it's going on. And then there's, of course, the up arrow, which allows the duck to jump, which is why it gets scaled up and comes out at the screen. So anyways, that's the game overall. And then if you hit an obstacle, game over. If you get to the end, you'll reach dry land, and then there will be a different splash screen for beating the game. Thank you for watching.